We start off with the fifth and the final class of the chapter sequence and series. Now, in this class, we are going to discuss two small topics. The first one is geometric mean, and the second one is special series. So, to begin with, now, as you have already done arithmetic mean, the geometric mean is almost similar, but with a little bit of difference. The difference being, if I have the numbers a1, a2, a3 up till an, now obviously they need not be in any kind of progression or anything, they can be any set of number, then the geometric mean of all these numbers is given by the nth root of the product of these numbers. Fine. Now, as I was telling you, there was a slight difference. The slight difference being that in case of arithmetic mean, you need not actually worry about what kind of numbers these are or what is the sign of the numbers. But here, in this case, you need to worry a little bit. Why? Because you are finding the nth root, and whenever you are finding the root, then there always comes the question of taking the plus sign, taking the minus sign, or if you are taking higher roots, then there is a question of complex roots as well. So the point is, we are discussing this keeping in mind that all these numbers that which we are talking about, they are all positive. It's just like making things simpler. It is not necessarily that all the numbers has to be positive, but we are kind of keeping our discussion in the realm of positivity. So we are just keeping it there. Now, also, you can ask which one to take, the positive one or the negative one. Well, there you have the liberty to take either of the two, depending on the sequence, the way it is given. But in general, we take the positive one. Fine. Now, if I have two numbers a and b, then from the above definition, the geometric mean of these two numbers is given by the product of the nth root. Now here, as there are two numbers, so it will be the square root of the product. So it is root over of ab. Fine. So from here you can see that a and b has to be of same sign. So why I have written this instead same sign? Because if you take two negative numbers as well, then also you can get a geometric mean. So geometric mean is not that as easy as it is in case of arithmetic mean, because there's a square root or root involved, so there comes a lot of problem along with the roots. So positive sign, negative sign, complex or real. So we are keeping everything real in this case. So everything is positive, for the matter of fact. Now, same as that of arithmetic mean, if I take the geometric mean and the two numbers, and if we place them in the right order, they form a geometric progression, right? And for any two number a and b, the arithmetic mean is always greater than or equal to its geometric mean. Now, it can become only equal if the numbers are same. If the numbers are not distinct, that is a and b, they are two same numbers. If that happens, then the arithmetic mean becomes equal to the geometric mean. But otherwise, if we have two distinct numbers, then the arithmetic mean is always greater than or equals to geometric mean. Now, how to prove that? Now, we start off with a minus b whole square. Now, a minus b whole square, that is something which can be written as a plus b whole square minus 4ab. Now, as I have started off with the square of a number, now I know square of any number, any real number for the matter of fact, is always greater than or equals to 0. So a plus b whole square minus 4ab is definitely greater than or equals to 0. And from there I can write a plus b whole square is greater or equals to 4ab. You take the square root both sides, and then you get a plus b is greater or equals to 2 root ab, or that is a plus b by 2 greater or equals to root ab. So this is basically your arithmetic mean, and this is your geometric mean. So therefore am is greater than or equals to gm. Fine. So that's what you prove. Now, like again the last time, we have inserted numbers of arithmetic mean between two numbers. So we are going to do the same here as well, that we are going to try to insert as many geometric means as we can between the two numbers. Now let, in this case, g1 g2 up till gn be the n geometric means between a and b, and by following the definition of geometric mean, all the geometric means in between a and b along with a and b forms a geometric progression. Now in that case, a is the first term and b becomes the n plus 2th term, right? So therefore b can be written as a r to the power n plus 1, where r is the common ratio between all these terms. So r is basically b by a whole to the power 1 by n plus 1. So this is the formula which we need to focus on. Now from this formula we are going to find the value of the common ratio, and from there I can get all the values of all the different geometric means. How? The geometric mean, the first one, g1, is the second term, so g1 can be written as ar. G2 is the third term, so it can be written as ar square, and so on till gn, which is the n plus 1th term, that can be written as ar to the power n, right? And also you can prove this, that product of all the geometric means, all the n geometric means, is basically the nth power of the single geometric mean between a and b. As you had in case of arithmetic means, that sum of all arithmetic means, that is a1 plus a2 plus dot 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 plus an, was basically n times the sum of single arithmetic mean. So this is exactly the same thing, the similar kind of theory, that is product of all geometric means is equals to the nth power of the single geometric mean. Okay, so now let us move to question number 1. Insert 5 geometric means between 576 and 9. Show that their product is the 5th power of the single GM between the numbers. Now, to begin with, A is given 576, B is given 9, so I need to find out the common ratio R. Now, just remember the formula for the common ratio. It was B by A whole to the power 1 by n plus 1. Putting all these values, I get the value of R as half. So therefore, the geometric means are basically AR, AR square, AR cube, and so on. So therefore, that is 288, 144, 72, 36, and 18. Now, the second part is I need to find the single GM. Now, what is the single GM? That is square root of 576 into 9, that is 72. Now, the next part, that is show that their product is the 5th power of the single GM. So all you need to do, find this product and find 72 to the power 5. So if you find these two, you will see that these two are equal. Fine. So I'm leaving it for you to do it or check it. Number 2. The AM of two numbers exceeds their GM by 2. The ratio of the two numbers is 4. Find the numbers. So let me consider the two numbers be A and 4A. Why? Because it is given that the ratio between the two numbers is 4. So therefore, if I consider one as A, the other can be taken as 4A. Or you can take A by 4 as well. So both are going to give you the same answer. Now, it is given that the AM of the two number exceeds their GM by 2. So let us first find their AM and GM. So what is AM? AM is sum divided by 2, that is 5A by 2. And GM is square root of their product, so that is 2A. Now it is given that the AM is equals to GM plus 2, or from there I can solve and I get the value of A as 4, and hence the two numbers are 4 and 16. Fine, simple problem. All you need to do is just understand the language of the problem. Number 3. If A1 and A2 are two AMs and G1 and G2 are two GMs between two positive numbers A and B, then find the value of A1 plus A2 by G1, G2. Now, what is A1, A2? A1, A2 is basically twice of the single arithmetic mean. Now, what is the single arithmetic mean? That is A plus B by 2, that gives you A plus B. And G1, G2 is basically square of the single geometric mean, so that is AB. And if you put all the values, so that's the answer. That's just it. You need not think of anything more than this. So it is A plus B by AB. All right, so this is the best you have from this particular topic. Now let us move to another topic, that is special series. Now before I start special series, I need to tell you this, that the problems or the examples of this particular topic is obnoxiously long. Means they are pretty long and tiring problems, means you have to do a lot of calculation there. But if you are given to do one, you have to be patient and calm to ensure that you solve the problem, because there is not much brain to apply. It's just that you have to do some tough physical work in solving the problems, and these problems can definitely come for 6 marks, means these are long problems. Now, what is special series? Special series is basically any kind of series which doesn't fall under a particular progression or particular type of series. So it is neither arithmetic progression, it's neither a geometric progression, or any other kind of progression there can be. So that is the reason why they are classified as a special series. Now, to begin with, the first one, that is sum of square of first n natural numbers. So how does it look? It looks something like this. So 1 square plus 2 square plus 3 square till n square. So you can see this is definitely not an arithmetic progression. This is not at all a geometric progression. So this is a different kind of a series, and that is why it is called a special series. So sum of the squares of the number. Now, sum of the squares of the first n natural number, this is the formula. Now obviously you can ask the very obvious question, from where the formula comes. It can be easily proved. Now I'm skipping out the proof just to ensure simplicity. Let us stick to the formula. If you want, I can prove it later if you have any doubt, or you can definitely go through a book where the proof is given. Then the next one, sum of cube of first n natural numbers. Same way, 1 cube plus 2 cube up till n cube, and that is n into n plus 1 by 2 whole square. Now in this, there is a third one, obviously, which I didn't mention, the obvious one. Now it's not supposed to be called as a special series. Why? Because it is pretty much an arithmetic progression, but as you require that formula to prove all these things, so let me just mention it separately. That is 1 plus 2 plus 3 plus dot dot dot, your old school formula, that is sum of first n natural numbers, that can be written as summation of r, or summation of 1 to n r, and that is basically n into n plus 1 by 2. Right? Now this doesn't fall under special series. This shouldn't be called as a special series, basically, because it is actually an arithmetic progression, and you already know the value of this separately. But these two are definitely special series, because they do not fall under any category of your progression or any other kind of series that we know. Okay, so now let us proceed to the problems. Now, as I told you that these problems are big, very big. So I have cut short the calculation, but ensure you do the calculation and check it all by yourself. I have just given you the idea how to solve it. Find the sum to n terms, 1 into 2 plus 2 into 3 plus 3 into 4, and so on. So you have to find the sum till n terms. Now, obviously, these are all individual terms. These are all individual terms. So this is the first one, this is the second one, this is the third one, and so on it goes. Now, obviously, to find the sum of the first n terms, first I need to find the nth term, which is important. I need to find Tn. Now, how to find Tn? Now, finding Tn can be easy and difficult as well. Easy if you can understand what is the pattern given here. If you can understand the pattern here, then it is easy to predict what is going to be the nth term. And if it is not easy to find a pattern, then there are other ways of solving it, which we are going to discuss a little bit later. So here I can see I can pretty easily predict the pattern. So what is the pattern? So you see the first term is 1 into 2, the second term is 2 into 3. So all you need to do is associate the term number that is here with all these two numbers present here. So here also this term number here. So 1 is associated with 1 into 2, 2 is associated with 2 into 3. So that means the term number and whatever the term is given has got some linkage. So you have to find that linkage, and that will give you the nth term. So if you see, if I go on doing it like this, then isn't it that Tn is basically n into n plus 1, right? So the term number and the values given, they are linked in this way. So therefore, what is the nth term? Nth term is n square plus n. So pretty much what we are trying to find out is we are trying to find out the sum. Now, what is the sum? Sum is basically sum of all the terms. So Sn, if I denote it by Sn, then that is equals to summation of Tn. Now, what is Tn? Tn is n square plus n. So that can be written as summation of n square plus n. Now, remember, sum, inside sum, if you have a plus or a minus sign, then that plus or a minus sign gets distributed over the sum. So it can be written as sum n square plus sum n. Now, what is sum n square? Sum n square formula is this. That is something which we just learned. And sum n is basically your old school sum formula. That is sum of first n natural numbers. And all you need to do is calculate this. Now, how to calculate this? Let me give you a very simple trick to do the calculation. Now, all the problems will have this particular trick applicable all the time. You see, n into n plus 1 by 2 is common in all the cases. Why? Because all the formulas will have a factor of n into n plus 1 by 2. So what you can do, take this common out. So if you take n into n plus 1 by 2 common out, whatever is left on these two terms, that in the first one it is you are left with 2n plus 1 by 3, and in the second one you have already taken the whole thing common out, so you are left with 1. So now all I need to do is calculate whatever the thing that we have inside the bracket, and then after simplification you get this value, right? So this is how you do the calculation. So this is your Sn. Now, many of you may find it difficult to understand what just happened here. Now, just to give you a small example, let us take this first three terms, right? Now, in this first three terms, just do our calculation and find the value. So this is 2, this is 6, this is 12. So 2 plus 6 plus 12, that is your 20. So this should be the answer. So in place of n here, put n equals to 3, because we have done sum of 3 terms. So if you put n equals to 3, then it becomes 3 into 3 plus 1, that is 4, into 3 plus 2, that is 5, divided by 3. 3 and 3 gets cancelled. You are left with 20. So that means what? If I want to find sum of this particular series given here up to whatever the number of terms I want, I can just put the value of that number of terms here in this formula to get that sum. Understood? So that's what we did. We found a generalized formula for finding the sum of this particular series. Let us move to number 5. Find the sum of 2n terms of this particular series, 1 into 2 square plus 3 into 3 square plus 5 into 4 square, and so on. So once again, let us find what is the association of the term number and the term. So T1 is 1 into 2 square, T2 is 3 into 3 square. And if I just look into it, so the first part, this part is basically the odd numbers, and here I have square of the next number. So from that way, I can say Tn is basically 2n minus 1 into n plus 1 whole square. Right? Now, from the previous one, this one is a little bit difficult in the sense to understand what is the association. Now you can always find a few more terms, just not only T1 and T2, you can find 3-4 more terms to understand what the association is. Then once you have understood, then write the nth term, and once you have written the nth term, all I need to do is find the sum. So what is Sn? Sn is basically summation of Tn. So summation of Tn means summation of 2n cube plus 3n square minus 1. So that can be individually written as summation of 2n cube plus summation of 3n square minus summation of 1. Now here, what is summation of 1? That is something which we need to talk about. Summation of 1 means single number 1 is getting added n times. You are adding this whole thing n times. So summation of 1 is actually equals to n. Fine. Now, all you need to do is summation 2n cube. So n cube formula is this, n square formula is this, and summation 1 formula is this. Now, you can see that this in itself is a room full of calculation which you have to do to simplify this out. Now, you may ask the obvious question that do we need to simplify? Now, the answer is yes. You definitely need to simplify. And just to ensure that happens, you can just take n into n plus 1 by 2 common, as I told you, from this first two term, do your calculation, or you can just square it up, take the whole thing at a time and then do your calculation, do it in whichever way you want. And if you do, this is what the answer you should get. So I have done a little bit of cheating. In this case, I haven't done the calculation, but obviously you get the idea that from here onwards, it is just simple normal algebraic calculation, which for a class 11 student, I'm pretty sure you can do it. Let us move to number 6. Number 6, find the sum to n terms, that is 1 cube plus 1 cube plus 2 cube by 2, 1 cube plus 2 cube plus 3 cube by 3, and so on. So again, we need to associate. The first term is 1 cube, the second term is 1 cube plus 2 cube by 2, third term is this. So you can see the nth term is basically, it is going to be sum of the cubes of the first n terms divided by n. So this is basically a series of series. This is series of series. Series of series means each and every individual term in this particular series are actually a series, if you can just understand. So yeah, it's mind-boggling, I know. It is very difficult to comprehend a simple series. So now you are dealing with a series of series. So yeah, give yourself some time. I'm sure you'll understand. So basically the idea is all the same. I found out the nth term. After I have found out the nth term, my job is to find the sum. So again, put it into the formula. That is sum Tn, that is 1 by 4 of n cube plus 2n square plus n. This will be like, again, a huge calculation, as you can see. And the good thing is here I can take n into n plus 1 by 2 common from all the terms. Do your calculation, and once you finish it off, you are going to come across something like this. Now, how to understand that you have done it correct? Again, what is the sum of these three terms? Just find out. 1 cube is 1. 1 cube plus 2 cube, that is 9 by 2. 1 cube plus 2 cube plus 3 cube, so that is 9 plus 27. Basically, 9 plus 27 is 36 divided by 3, that is 12. So basically the sum is 12 plus 1, 13. So 26 plus 9 is 35 by 2. So this should be the sum, right? Put the value of 3 here and just calculate. So if you just calculate, basically this is going to be 3 into 4 into 5 into 3n plus 5, that is 3 3s are 9. 9 plus 5 is 14 by 48. So 4 and 48 cancel, that is 12. 12 and 3 cancels, that is 4. and 4 and 14 cancel. This is 7, this is 2. So therefore you are left with 35 by 2. Right? So this is how you check if you have done it correct or not. So for the first 3 terms, I can see this is coming out to be true, and pretty much it will definitely come out to be true for any number of terms that you take. So you can take that many terms, find the sum separately, and then put the value in the formula and calculate and check if you are getting the same or not. So that will just give you an idea you have done the thing correct. Okay. Now let us move to the 7th and the last problem. Now here this is a problem where we can't actually associate the term numbers with the terms. We can't actually find the linkage between the term numbers and terms here. So why? Because it is pretty random. You see, T1 is 3, T2 is 7, T3 is 14. I mean, there is no linkage between this term number and this. There is no linkage at all. So you can't find what is going to be Tn. So for that there is a method, and that is called the method of difference. So it is called method of difference. Now what do we do in method of difference? So we first write Sn equals to this. So 3 plus 7 plus 14 plus 24 plus 37 plus till Tn. I don't know what is Tn, so let me write that. Then I write the same thing but shifting one place to the right. Now next my job will be to subtract this. Now if I subtract, what happens? Let us see. Now let me just draw the line under here to make you understand what is going on. So 3 comes down as 3 because there is nothing underneath it. 7 minus 3 becomes 4, 14 minus 7 becomes 7, 24 minus 14 becomes 10, 37 minus 24 becomes 13. And how many terms there will be? Obviously this Tn is here, so Tn minus 1, so there will be n minus 1 terms, and this last Tn that we have, that will be just subtracted because there is nothing here, so it will be minus Tn, right? So from there I can do what? I can take this Tn on the other side, so that gives me Tn is equals to 3 plus 4 plus 7 plus 10 up to n minus 1 terms. Now here you see this is basically an AP, right? This forms an AP. So therefore the nth term is basically this. So you see, if I would have been able to find the association with the term number and the term, then I could have reached this particular step directly, which I did for the all previous problems. But here, as I couldn't associate, what I did make use of the method of difference, and from there I got the nth term. Now next job is pretty simple. I need to find the sum. So that sum, again, if you just do the summation of 3n square minus 4 plus minus n plus 4 by 2. Again, I have done the same cheating. I haven't done the calculation, but yes, you can always check if it is coming or not. So it is half so you can just find the sum and then you can check. So here let me do it for you. So 3 plus 7 plus 14, that is 24. So 3 plus 7 plus 14 is 24. Let us take the first 3 terms. So 3 plus 7 plus 14 is 24. Now put the value of n as 3 here. So that is half times 3 into 3 square plus 3 plus 9 plus 3 plus 4. So 9 plus 3 is 12, 12 plus 4 is 16, 16 divided by 2 is 8, so that gives you 24. Now again, if you want a different value, let us take a different value. Let us take all these 5. So 3 plus 7 is 10, 10 plus 14, 24, 24 plus 24 is 48, and 48 plus 37, that is 85, right? So let us put the value 5 here. So if I put the value 5, so half into 5 squared is 25 plus 5 plus 4. 5 plus 4 is 9, 9 plus 25 is 34, 34 divided by 2 is 17, 17 into 5 is 85, right? So you can see that this actually is true. so the calculations are correct. So all you need to do is you need to do this calculation. That's it. And this method of difference is very useful if you can't actually associate the terms, and you can make use of this in the previous problems as well. You could have done that as well. So, but it is going to be a little bit tedious process. It is always good to first check if you can associate the terms with the term number. That will give you the nth term very easily, and if not, then go for this. Okay, so that's our class. That ends the chapter of sequence and series, and as always, if you have any doubt, please get it clarified. Thank you.